I'm going to go ahead and talk about Pythagorean Theorem now, how it's used. So the formula is a squared plus b squared is equal to c squared. And where c represents your hypotenuse, it's always across the 90-degree angle. So one thing I'm going to suggest is to always find your 90 and just draw a quick line across from it, and that's going to be your c. Pythagorean Theorem can only be used if it's a right triangle and you already know two sides. If it's not a right triangle, you can't use it. If you only know one side, you can't use it. So I'm going to go ahead and provide you some examples where what if you're solving for A or B or C, right? I'm going to do this without numbers because I ultimately want you to see how the final solutions are so related. So let's say we were solving for C. All right, so according to this Pythagorean theorem, right, is a squared plus b squared is equal to c squared. So if we were solving for c, if we were solving for our hypotenuse, we could just rewrite it so that we could have the c in front. And if I'm solving for c, right now it's being squared, I just got to do the inverse operation, which is to do a square root. And so c would be equal to the square root of a squared plus b squared. And so as you've noticed on most of the other videos where I use Pythagorean theorem, I don't even bother with this step, I go straight to this. And the important thing here is noticing how we have a square root and we're adding inside the square root because we're solving for our hypotenuse, which should be the biggest side. Versus if you were solving for A or B, it doesn't really matter. If you were solving for a leg, in this case I'm going to pretend I was solving for A. Now A and B are interchangeably because when you label, C is the only one that matters. So it initially starts the same, a squared plus b squared is equal to c squared, right? But this time I am solving for a. So anything that's not an a, I'm going to move it to the other side. In this case, I'm going to move it by subtracting. So this becomes a squared is equal to c squared minus b squared. And once again, to get rid of the square, I do a square root. And so a is equal to the square root of c squared minus b squared. So again, the important thing here you're noting is whenever you're solving for c, you're adding. Whenever you're solving for a or b, you're going to end up subtracting. If you were solving for b, it's literally the same thing, except you have b here and a here. Please don't forget, solving for c, you add. If you already know c, you subtract. Okay, solving for a, aka you know c. All right.